Find the other trig values if the cos of x equals 4/5 in quadrant 1. So the first of all we need to do is draw an axis like this. And we're going to draw any triangle in quadrant 1. And the right angle is there. So we know that cos x, there's x. We know that the cosine is 4/5. So we want to find out the missing side. So we know that by Pythagoras, 5 squared equals question mark squared plus 4 squared. So 25 equals question mark squared plus 16. And question mark squared equals 9. So the missing side is 3. So it's a 3, 4, 5 triangle. And now it asks us to find the 5 other trig ratios. So sine x is going to be opposite of hypotenuse, 3/5. Cos x we've already got. We know we're given that is 4/5. Tan x is opposite over adjacent, so 3/4. And then coming back the other way, we know that cosec x is the reciprocal of sine, 5/3. Sec x is the reciprocal of cos, so 5/4. And cotangent x, or cot x, is the reciprocal of tan, 4/3. So again, find the other trig ratios if sine x equals 3/4 in quadrant 2. So we draw our axis down like this, and we get a triangle in quadrant 2. Put the right angle there, and our x is here. And we know that sine is 3/4, so the hypotenuse is 3, 4, opposite is 3. By the process of Pythagoras, we know that c squared is 16 minus 9 is 7, so this is going to be √7, and it's going to be negative because it's going in the negative x direction. 4 squared is 16, minus 3 squared is 9, 16 minus 9 is 7, √7. So therefore we get sine x, we got cos x, we know it's going to be adjacent over hypotenuse, so negative √7/4. Tan x equals opposite over adjacent, so 3 over negative √7. And we rationalize by multiplying by √7/√7, and we get negative 3√7/7. Coming back the other way, we know that cosec x is the reciprocal of sine, which is given in the question, therefore 4/3. Sec x is the reciprocal of this one, cos, so negative 4/√7, and we multiply by √7/√7, and we get negative 4√7/7. And cotangent x is the reciprocal of tan, and we take this one to turn upside down, and we get negative √7/3. So we get tan is 2/3 in quadrant 3. Interesting question. There's a little bit of a trick to it. So we draw a triangle in quadrant 3. There's our triangle. Again, it's coming out of the origin. We know that this is our angle x, even though the radius arm has travelled that angle. So we know that tan is 2/3. So we know that the opposite and the adjacent would give me that. There's a mistake here because both of these have to be negative because the x is going down and the x is going left and the y is going down. Therefore, we're in negative territory for both x and y down here. Trick question. Pythagoras, negative 2 squared is 4, negative 3 squared is 9. Add them together, we get 13. So the hypotenuse is √13. The radius arm, incidentally, is always positive. This is always a positive distance. Can't be negative, even though the x, negative 3 is negative, and the negative 2 is x down there. Let's go through and find the values. So sine x equals opposite over hypotenuse, negative 2/√13. Cos x equals adjacent over hypotenuse, so negative 3 over root 13, and tan x is given in the question, 2/3. So we know that cosec now, going down the other way, is this one turned upside down. In fact, I made a mistake here because I should have rationalized these. Sorry about that. It's root 13 over root 13. Gives me negative 2 root 13 over 13. And this one, if we did the same thing, would be negative root 13, 3 root 13 over 13. And cosec coming the other way is turn this one upside down, so negative root 13 over 2. Sec x, reciprocal of cos, is going to be negative root 13 over 3. And cot x, reciprocal of tan, 3 over 2.